Let's analyze this equation's graph by thinking about the intercepts and thinking about any symmetry that might be involved. Remember, to find the y-intercept, of the graph of the solution set of an equation in two variables, we let x be 0 and solve for y. Well, y is going to be 5, isn't it? Negative 2 times 0 is 0. 0 plus 5 is 5. So the y-intercept here is the point 0, 5. And then to find the x-intercept, we let y be 0 and solve for x. Well, here I'd add 2x to both sides, possibly. And then, divide both sides by 2. Get that eventually. So here, the x-intercept would be 5 halves 0. Now, as far as symmetry is concerned, we recognize what the graph of this equation's solution set looks like. That would have to be a straight line, wouldn't it, since this is a linear equation in two variables? Would there be a straight line that would exhibit any symmetry? Could we have a straight line that would exhibit symmetry with respect to the y-axis? If we think about the x and y-axis, could we draw a straight line that for every point that we had here, there would be a symmetric point over here? Well, there would be one kind of line. Wouldn't a horizontal line exhibit symmetry with respect to the y-axis? Any point here, there's also that corresponding symmetric point over there. How about symmetry with respect to the x-axis? Would there be a line we could draw that if you had a point here, there would be a corresponding symmetric point here? Well, wouldn't that be true if we had a vertical line? Wouldn't, for every point here, wouldn't there be the corresponding symmetric point here? Every x, y, we would also have the x minus y point. For every xy point here, we'll have the minus xy point here. That gives us symmetry with respect to the y-axis. How about a line? Could we draw a line that would have symmetry with respect to the origin? Well, wouldn't a line that passed through the origin? If we had the point here, wouldn't there be the corresponding symmetric point here? Say, for an example, a line that was something like this, y equals 3x. If x is 1, y is 3. If x is 1, let's say that's the point 1, 3 right there. Well, isn't the point negative 1, negative 3 also a solution to that equation? So every point xy, there is the corresponding minus x minus y. So this would be an example of a line that had symmetry with respect to the origin. But this line is not going to be passing through the origin. It's not a horizontal line, not a vertical line. So that line has no symmetry at all. It's not symmetric with respect to either the axes or the origin. So again, here's another example where we can learn something about the graph of an equation's solution set by analyzing symmetry and intercepts.